Hi, Calculus 1 students. This is the last example, one of the last example, it's not the last actually, that I will ask of you in limit laws, section 2.3. It's an example to be done with the squeeze theorem. And the reason we know that is because if we were to directly substitute, this would give us 0, like the ln of x as x is approaching 1 is approaching 0. We see it from the graph over here. And the sine of 2 over x minus 1, the limit does not exist, because if you replace 1 here at the denominator, you're going to get 2 over 0. So this is the limit that oscillates like faster and faster. Like this factor right here oscillates faster and faster between 1 and negative 1 as x is approaching 1. That's your giveaway for the squeeze theorem, is if you have like an asymptote inside of a trig function. So how do we handle that? Well, the first thing to say is that when x is near 1, we know that the sign is between negative 1 and 1. 1 when x is near 1. Okay? Then we multiply every side of the inequality by ln of x. So we're going to have negative ln of x. We're going to have ln of x times sine of 2 over x minus 1. And we're going to have ln of x. Okay. There's one thing we need to be careful of, the inequalities. We have to figure out if they are maintained, if they are reversed, or if they just collapse, like if there's nothing you can say. So the way it works is, let's look at the graph of logarithm, right? Because we are multiplying every side by logarithm. Okay, so that's what we need to consider. We need to see if we're multiplying by a number that's positive or that's negative. Well, as x is approaching 1 from above, like this, okay, as x is approaching 1 from above, the logarithmic function is going to approach 0 from above, right? So let's actually write this down. As x is approaching 1 from above, ln of x is approaching 0 from above. What does it mean? It means that we know that ln of x will stay above 0. And because of that, the inequalities are maintained. We are guaranteed that ln of x is a positive number. All right, next. Since now there's different approaches, we can either ignore the 4 for now and just add it at the very end, or we can continue with the squeeze theorem. I will choose to continue with the squeeze theorem just because sometimes you cannot ignore that 4. It might be like inside of a denominator, let's say. So let's actually add 4 on every side. So what are you going to get? So you need to imagine that you do plus 4, plus 4, plus 4. So on this side, you're going to get 4 minus ln of x. Okay, so here, 4 minus ln of x. Here you're going to have 4 plus ln x sine of 2 over x minus 1. And then you're going to have here 4 plus ln x. Now you're adding something on every side. The inequalities are always maintained in that case, regardless of what that number is. Even if this number is negative, even if you were to subtract something on every side, the inequalities would still be maintained. And now you're very close because you succeeded in getting this limit. So now the idea is to say that this thing, you know, it's approaching 4. Yeah, this thing is approaching 4, and this thing is also approaching 4 as x is approaching 1 from above. So basically, you do the limit of this and this, and you get the result of 4. So as a result, by the squeeze theorem, you know that the limit of this is also 4. So the limit as x is approaching 1 from above of 4 plus ln of x sine of 2 over 1 minus 2 over x minus 1 is equal to 4 by squeeze theorem. So here's your answer, yeah. I hope that's clear. See you in the next video.